In this video, we're going to use the same ideas that we used to find the volume of irregular shapes in order to find the mass of objects with a changing density. Because mass equals volume times density. Now if we have an axis on which we lay a 10 centimeter long thin rod with a constant cross-sectional area of 1 centimeter squared, then the mass of each slice would equal the volume, which is the cross-sectional area, times the height. So it is 1 times the height, which is delta x centimeters, times the density, which is given by rho of x, and that is in grams per centimeter cubed. Then our mass is equal, our mass slice equals rho of x times delta x. And this would be in grams because the centimeters will cancel out. Now, if we were to apply this to find the volume, to find the mass of the entire object, we're going to use an infinite amount of infinitely skinny slices. I've written down that rho of x equals 2e to the negative 0.2x. So we are left with that equaling the integral from 0 to 10 of rho of x, which is 2e to the negative 0.2x dx. And that, at this point, we know how to do anti-differentiation, so we can use technology. And this then equals 8.65 grams, given that this is grams per centimeters cubed. Now, in order to make sure we did the slice right, we can go back and say that m slice equals the cross-sectional area we established as 1 centimeter squared. So 1 centimeter squared times delta x centimeters, since that's just in one dimension, times 2e to the negative 0.2x. That is in grams per cm cubed. So when we cross out all of that, that equals 2e to the negative 0.2x delta x grams. Now when we integrate that, we get from 0 to 10, because we're doing the whole 10 centimeters of the rod, 2e to the negative 0.2x delta x becomes with respect to x, and like we said before, that equals 8.65 grams, because mass is in grams. Now we can apply this to find work over distance, because work equals force times distance. So for this problem, we have a cliff and a heavy rope that starts 200 feet long and weighs 0.3 pounds per foot. So we're going to label this as our x-axis, and this is our y-axis, which are inverted because this is now dependent of this. So our force in terms of height equals 0.3 times 200 minus the height, because total weight will be 0.3 times 200, but then after the course of 200 feet have been lifted, there will be zero force. So if we integrate from 0 to 200 of 3 times 200 minus h with respect to height. We can use technology to solve that, and we should get 6,000 foot-pounds. So here's a question. You have a 7 centimeter long thin rod with a constant cross-sectional area of 1 centimeter squared, and a density function that is modeled by rho of x equals 3x grams per centimeter cubed. Go ahead and pause it and see if you can solve yourself.